Imagine looking through a telescope tonight and discovering that Jupiter, the largest planet, has simply vanished. Would Earth be destroyed instantly? Would planets crash together? The real answer is slower and far more unsettling. Jupiter contains 318 Earth masses and more mass than every other planet combined. Its gravity quietly shapes moons, asteroids, comets, and even the motion of the Sun itself. For this experiment, Jupiter does not explode. Its mass simply disappears in a single impossible instant. But gravity does not update everywhere instantly. The change spreads outward at the speed of light. Depending on where the planets are, Earth learns Jupiter is gone tens of minutes later, not immediately. When that moment arrives, you feel nothing. The ground does not shake, and the oceans do not rise. Earth still orbits the Sun because solar gravity dominates our path. We are not thrown into space. For Earth, the first day looks normal. The catastrophe begins in the empty space Jupiter left behind. Jupiter's moons suddenly lose the planet that curved their motion into orbit. They do not stop. Each moon continues with its existing speed and begins a new solar orbit. Europa, our famous ocean world, becomes a small wandering world circling the Sun. Io loses Jupiter's crushing tidal pull, and its extreme volcanic engine begins to weaken. Ganymede, larger than Mercury, survives, but no longer travels as a moon. Dozens of smaller moons spread onto chaotic paths, creating a vast swarm of orphaned objects. Some may collide, others may be ejected, captured, or pushed toward the inner solar system. Europa would lose tidal heating, but its buried ocean would not freeze solid overnight. The 4 Galilean moons become independent worlds, each carrying Jupiter's history into a new orbit. And the moons are only the beginning. Jupiter controls far more than its immediate family. Jupiter's gravity has sculpted the asteroid belt for billions of years through powerful orbital resonances. Those resonances created gaps, shifted orbits, and prevented many objects from settling into stable paths. Remove Jupiter and the belt does not explode. Most asteroids continue moving around the Sun. But over decades and centuries, missing resonances allow countless trajectories to evolve differently. Jupiter's Trojan asteroids lose the stable gravitational balance that held them near 2 special regions. Most become ordinary solar-orbiting asteroids. A fraction could enter unstable or planet-crossing paths. Close encounters with Mars and other objects can then redirect some of them farther inward. This does not guarantee an impact on Earth. Space is enormous, and collision probabilities remain small. The danger is statistical. Change millions of orbits, and eventually some new paths threaten planets. Humanity might have years of warning, but an altered asteroid population could become our first serious consequence. Jupiter is often called Earth's shield, and we have watched it capture and destroy comets. Its massive gravity can deflect dangerous visitors or swallow them before they reach the inner planets. But the shield is imperfect. Jupiter can also redirect objects inward instead of safely outward. The giant planet is both guard and gatekeeper, removing some threats while creating routes for others. Without Jupiter, some incoming comets would miss the gravitational encounters that once changed their fate. Some hazards could decrease. Others could linger longer in the inner solar system. The balance is complicated. Even the population called Jupiter family comets would gradually transform without the planet that defines them. So Jupiter's disappearance does not create an instant cosmic shooting gallery, but it rewrites future probabilities. The greatest danger unfolds across generations, not during the first terrifying night. And while small bodies wander, the architecture of the entire solar system begins adjusting. Jupiter is so massive that it and the Sun orbit a common center sometimes outside the Sun's surface. When Jupiter disappears, the solar system's center of mass shifts, and the Sun's familiar wobble changes. The Sun does not become motionless. Saturn and the other planets continue pulling it around the barycenter. Every planet keeps orbiting, but each now follows a slightly different gravitational solution. Earth's immediate change is tiny. The Sun still supplies overwhelmingly most of the gravity controlling us. Mars, Saturn, and the outer planets gradually change how their orbits precess and interact. Across millions of years, even small gravitational differences can produce very different arrangements. That does not mean every planet collides, the system would likely remain recognizable but permanently altered. Saturn becomes the dominant surviving planet, but it cannot simply replace Jupiter's former gravitational role. The solar system now has a giant missing gear, and every smaller gear must move without it. From Earth, the first visible loss is simple. One of our brightest night sky objects is gone. Astronomers would face the greatest scientific mystery in human history, and no known physics could explain it. Jupiter does not control our tides. The Moon and Sun continue raising oceans almost exactly as before. Weather does not collapse, temperatures do not suddenly plunge, and Earth's atmosphere stays in place. Our seasons continue because Earth's axial tilt and solar orbit do not depend directly on Jupiter. Far away, Jupiter's enormous magnetosphere disappears, removing a vast radio and radiation environment. Any spacecraft near Jupiter becomes stranded on a new path around the Sun, carrying one final record. Humanity's urgent task would be mapping every displaced moon, Trojan asteroid, and newly uncertain object. The disappearance would turn planetary defense from a scientific program into a civilization-level priority. Life continues, but future generations inherit a solar system whose long-term behavior is harder to predict. After a century, the former Jovian system has spread into a complex family of independent solar orbits. After thousands of years, close encounters begin amplifying differences that were once almost invisible. Some orphaned moons or asteroids may be thrown outward, perhaps escaping the solar system entirely. Others could encounter Saturn and be redirected, captured, or placed onto entirely new paths. Among millions of harmless paths, even one large Earth-crossing object could become historically decisive. But danger is not destiny. Advanced detection and deflection could prevent impacts that earlier civilizations could not. No short animation can predict every outcome. Precise answers require long-term numerical simulations. What the experiment reveals is not a guaranteed apocalypse, but Jupiter's enormous hidden influence. It helped shape the solar system's formation, moved small bodies, and influenced the environment where Earth developed. Our familiar solar system is not merely planets near one another. It is a connected gravitational machine. So if Jupiter vanished, Earth would survive the first day, and almost certainly the first generation. Yet moons would scatter, resonances would vanish, and countless future trajectories would be rewritten. Jupiter is neither a perfect shield nor a simple threat. It is the solar system's greatest gravitational architect. Now imagine the opposite. Jupiter remains, but you fall directly into it. Could anything survive? Subscribe to SciSparke and watch our journey inside Jupiter next. The answer is more violent than you think.